Hi everyone, we're going to be doing a video in our classroom today for watersheds, topic 4.6. Change it up a little bit. So watersheds are a really important topic when it comes to, especially when we're talking about human impacts and things like that, because there really isn't a watershed in the United States that hasn't been impacted in some way by people. So if you look over here on the screen, you can see that there is, this is a little map of our local watershed. We live right in the middle here between the South Fork American River and the Middle Fork American River. And we're on the Georgetown Divide, right? So this watershed is a really important one because it runs into one of the largest rivers in our state, the Sacramento River. All the water that flows by us eventually goes into the Folsom Lake. So the basics, it's if you've ever played with water at the beach or made little rivers, digging in the sand on a lake shore, you know that water will follow gravity and always finds the lowest point, always flows downhill. Watersheds vary in size and shape. You can refer to a watershed as being very local, right? So right here where we are in Johntown Creek, right? It runs right through the park there. We could say this is the Johntown Creek watershed that the Golden Sierra is sitting on. But you can talk much larger, of course, right? The American River is a much larger watershed. So all watersheds share several key characteristics, and we'll talk about those in just a second. And then watershed contamination can come from point source or from non-point source pollution. So a point source pollution is maybe from a single source, could be like a dam or a mine, something like that. When non-point source pollution tends to come from a larger area. So it could be, oil washing off of roads, things like that. Okay, so the characteristics of a watershed are, so this is a definition, is the land from which all the surface runoff flows into a single water body. So a stream, a lake, a river, something like that, pond. The divide is that line marking the highest point around a large body of water. So Georgetown sits right on the Georgetown Divide. That's why it's called that, because it's sitting right at that point that separates the watershed flowing into the Middle Fork American River and the watershed flowing into the South Fork American River. So it's sort of that boundary line where a raindrop, falling on one side of the divide will flow into the Middle Fork. Raindrop flowing on the other side, landing on the other side of the divide, will flow into the South Fork. Tributaries are smaller streams and rivers that feed into the main river. And so, for example, little Johntown Creek here behind us that's in the park, it's a tributary for the South Fork American River. And then a river is a main source of water flowing into the largest water feature in that region. And then a delta, if you guys are, if you guys like to fish, you might have fished down in our Sacramento River Delta, which is famous for all of the fish that you can find in there. They tend to be very productive ecosystems because it's like an estuary, a lot of productivity there. This is where the largest tributaries empty into the main body of water. Usually it's a lake or ocean, and it's located, let's see if we can get rid of that, at the mouth of a river. Okay, all right. So here's the divide right there. Sort of, I'd say the divide is more up here, actually. I don't think that arrow is really in the right place. Tributaries would be all these little streams. The river is this main one. These arrows aren't landing where they're supposed to, but that's okay. And then the delta is going to be right here where it opens into this lake. Okay. So this I just took off of Google Maps, and it shows, this is a satellite view of our local area here. And if you look, there's Cronin, there's Greenwood, right? And here, this is because I, did this at school. Here we are right here at Golden Sierra. So you can see that here's the Middle Fork American River here. And then the South Fork's a little bit harder to see just because it doesn't have as steep of a slope going into the river there. But there's Coloma, so you can see the river valley down in here, right? And then down here, this is the top of Folsom Lake where it meets up at Rattlesnake Bars right there. And then here's the other, just kind of the top end of it. So this whole area here is the dividing line between, you can actually see it here, right? between two watersheds. So if you were to look at a map of the watershed, there'd be one over here and then one over here. Okay. So there's different factors that can impact how well a watershed drains. One of those is vegetation. So the more vegetation, the more vegetation that a watershed has, that usually means that the water will be retained more and it won't run off as easily. It's going to have more time to soak into the ground, infiltrate into the ground. And so that's really important. And especially when you're looking at, human impacts, you always want to look at that. And there's rules about how much vegetation can be removed near streams. Slope makes sense, right? The steeper the slope, the faster the water is going to move through it, which means it's going to run off faster. It's going to have less time to infiltrate and get into the groundwater. And then, of course, soil permeability. If you watch the other videos on soil, you know that permeability means how fast water can move through soil. So more soil permeability means water will infiltrate soil better and it won't just run off. So where we are here, we have a lot of clay in our soil, which means that it takes a long time for water to soak in and permeate into the ground and eventually move into the groundwater. So if it rains really hard, like that big rainstorm that we had in December, and the snow actually probably helped because it has time to soak into the ground. But if it rains really hard, often that water just doesn't have time to infiltrate the soil and just runs off. If you lived, farther down the valley or somewhere that has more of like a loamy soil, water will actually flow into it more easily. I don't know what happened here with my animations. Oh, there we go. So damming can impact, it is definitely one of those things that can impact a watershed. And then deforestation. So clear cutting is as a method of logging that removes all of the trees from an area. And you can see that if it rains, there's not a lot of vegetation holding the soil together here, and the water is going to run right off, often taking a lot of the soil with it into a stream or river. And you guys might remember, when a few years ago, oh, you guys are pretty young though, aren't you? So a few years ago when we had the King Fire, it's up at Stumpy, if you went up to Stumpy after the King Fire, after all those trees were lost and in that fire, that lake really filled up with sediment due to all that water that, from rain washing all that soil down into the lake. All right, so some physical characteristics. So if you guys remember from your aquatic ecosystems video, the aquatic portion of a watershed is called a lotic system. And there's 3 zones. Okay, there's the source zone, also called the headwaters, and it's fed by precipitation or snow and ice melt. And for us here in California, a lot of our streams, a lot of our watersheds are dependent on snow where we are in the Sierra Nevada. So usually our source waters, our headwaters, tend to be really high in oxygen. They're cold, they're narrow, the water is usually fast moving. There's not a lot of productivity up there. There's not a lot of plants. So there's fewer fish. And, we know that that's a good place but trout prefer high oxygenated waters like that. It's a good place to go look for trout. Then the transition zone is that portion of the system between the head and the mouth. So that's where most of the water is. That's where most of the, when you think of a river system, most of that's going to be in the transition zone. So it tends to be a little warmer, wider, less oxygen. Tends to be more fish though, because there's more productivity and more, bugs and things like that. You have more, just because there's more plants, there's going to be more animals living on those plants. And then the last part would be the floodplain, which is usually flat and wide. It's an open space along the river. And in a natural system, that would be flooding seasonally, right? And it'd be bringing a lot of those nutrients out into the soils. So this is, but for people, it makes it hard for us because we don't want to live in an area that's flooding all the time. So we tend to keep rivers from doing that. Usually there's turbid waters here. There's usually a lot of productivity. Lots of wildlife, often in floodplain zones. So this is the source zone, stream. This stream area is the transition zone, and then the floodplain would be down here, closer to the delta. When it rains, it either falls on the surface and runs off into the tributaries, and eventually the main water body, or it infiltrates into the ground and becomes part of the groundwater. And this is important because that groundwater, for especially if you're living somewhere like where we live, and we don't get rain most of the year, is that groundwater is really important for trees and plants and for us, right, for our wells and things like that, because we depend on that groundwater for accessing the rest of the year. So here's our American River watershed. And if you look at it, we can see that our source zone is going to be way up here where a lot of our little reservoirs are, right, up in the Rubicon. We have, all these little tributaries. If you've been up to Union Valley, there's Big Silver up there and the Jones Fork. Those are all source zones. Those are all headwaters. And then they all kind of come together, right, into the middle fork here. You can see that there. And then here's the South Fork. So where we are is probably like right in here somewhere, right on the divide. Okay. And I have a picture here of, this is the Rubicon River. So this is a source zone, right? It's a fast moving stream. Usually it's narrower. There's going to be a pretty cold water up here. You can see the snow up in the mountains right around it. And then here is our transition zone. This is down in Coloma. And the river's still moving kind of fast, but not nearly as fast as it is moving up high. Slower, it's a little warmer, it's deeper. Banks aren't as steep. And then here's, eventually it runs into the Sacramento River, and this is the Sacramento River. And the rivers and floodplains will do this wonderful meandering, right, where eventually they can actually cut off little sections and become oxbow lakes and things like that. So this area normally would flood every year as in the springs when all that snow melt comes down. But because that's a problem for us, we tend to build levees and things like that to keep the water from doing that. Okay, so here's just another couple really nice floodplains. You can see this one. I'm not actually sure where this one is, but it's very beautiful. And here's another floodplain. This is how it would look more. This is how floodplains often look naturally, especially as they get closer to the sea. All right, so here's when we look at the big picture, there's several continental divides in North America. This is the largest ridgeline for a very large watershed. So we're talking kind of huge areas here. So continental divide dictates which large water body precipitation will eventually flow into. And if you've ever done a road trip over in this area, you can actually drive across the Great Divide. It separates the Pacific and Atlantic watersheds. So that means that rain falling on this side, so it goes right through like Idaho and Wyoming, will all eventually flow into the Pacific Ocean. And rain falling on this side will eventually flow this way, probably into the Mississippi, and then down into the Atlantic Ocean. The Eastern Divide separates the Atlantic here and what will flow into the Mississippi. The Mississippi is a huge watershed. Basically, all of this area here in the middle is all going to eventually end up in the Mississippi River. And then the Arctic Divide separates Arctic and Hudson Bay. That's here. So we have rain, precipitation lands here will eventually flow up this way, and precipitation here will flow into Hudson Bay. Laurentian separates Hudson Bay and St. Lawrence. That's the green line right here. And then the St. Lawrence separates St. Lawrence and the Atlantic. And then the Great Basin right here, actually part of that's in California, feeds itself, which is interesting. And that's where most of Nevada is, part of Utah. So that means that rain falling on this side over here is all going to actually flow into the Great Basin and never actually leaves. Okay. So here's the thing with watersheds, is water carries materials with it as it flows downhill. And humans, oops, typo, sorry about that. Humans can impact a watershed in many ways. So like I said, deforestation, clear cutting, logging removes vegetation, increases runoff and soil erosion. Right? So which can eventually, that soil erosion all that sediment can actually fill up and dam tributaries and make flooding worse eventually. Development can alter the flow of water through a system by increasing erosion, like through construction, runoff, or by physically altering the course of a waterway. And this happens a lot, especially when you have housing developments. You don't want them to be flooded or have problems with streams running through, so they tend to be contained, right? We put a lot of things into gutters and culverts and things like that, and so we really alter the flow of all water that runs through a developed area. Impermeable surfaces are also an issue. So blacktop and concrete can limit water infiltration. And the water just runs off and often picks up a lot of oils and contaminants like that when it does, right? Guys might know about driving after a rainstorm when it hasn't rained in a while and how slick the road can be, right? And how it can be pretty dangerous. So, and all that oil eventually gets washed off, and it gets washed off into the soil and eventually down into rivers and streams. Farming, so waste from cattle contaminates the ground and surface water, which can be a big problem. It can introduce a lot of bacteria and a lot of nutrients into watersheds that can be a problem and cause something called eutrophication. Fertilizers also contribute to contamination, and we'll talk about that more, what some of the issues that can lead to. Industry, so hazardous waste and heavy metals can leach out and contaminate water supplies. So factories, things like that, and that's why we have a lot of that's why we have the Environmental Protection Service and laws about what kind of waste factories can be producing. And then damming disrupts the flow of water through a system, drastically impacts life above and below the dam. So where we are in California here, there used to be runs of salmon that would run right up the American River. I remember reading an article about how during the gold rush, they used to see sea lions sometimes down at the confluence, which, if you drive down from Cool to Auburn, when you cross the river there used to be sea lions sighted there because they would be coming up the river looking for salmon. And all of those runs of salmon are gone because they can't make it up the streams anymore to where they used to spawn. So if we catch the salmon right down in Nimbus, down in the south, down in the lower American River, and basically collect them, raise them in captivity, and then release them again. But we've still lost most of our salmon runs. Okay. This is why it's important not to let chemicals drain into storm drains and things like that, because a lot of those storm drains end up going straight into a watershed. This picture here is algae, which is what happens when there's a lot of nutrient runoff from fertilizers that cause algae to grow really fast. And when they grow so much in a stream like that, they actually when they die, the decomposition robs oxygen from the soil, from the water, and fish and insects and things can't live anymore. And that's the problem with eutrophication. And we'll be reading an article about that this week. Okay. Oh yes, there's runoff. Okay, so recap. Water flows downhill due to the effect of gravity. All watersheds share specific characteristics. The size, topography, slope, and soil structure and vegetation all have an impact on water flow in a watershed. Water flowing through a watershed tends to carry debris and pollutants with it as it flows downhill. And human activities can influence watersheds in multiple ways. Okay, I hope you enjoyed seeing my face instead of Mr. Smead's for a change. And please make sure you write down something you learned or questions you have about this topic, and we'll be going over it in class. Okay? Have a good evening. I'm pretty sure you're watching this in the evening, as usual.